have Tom, Chalk Connect, talking about how to create an app using Flutter. So Tom is our, head of technology, CTO, MD, everything at Switchplane, and he has worked on numerous apps over the years, including grassroots suicide prevention Stay Alive app, which has had nearly 1 million downloads worldwide. So he's got some credentials in the app world. So I'll pass over to him and let him tell you more about app making.
Thank you very much. So yeah, as Sarah said, we're a bit low on numbers. We didn't even know if we were going to do this session today because we weren't sure if anyone was actually going to show up. But we thought we'd better do something just in case new people arrive. So we thought, so I just said, yeah, all right, I'll do something. And I said that just before I went on holiday. And then I came back from holiday, to work today. And I realized I had nothing to show. So I thought, well, I've got to put something together. So this is flying by seat of pants. So what is Flutter? So I want to talk a bit about app development. And the framework that we use at Switchplane is called Flutter. It has some really good benefits to it, which I've listed here. But I guess the most important or most valuable part of it is that it's development from a single code base. So you can target multiple platforms, so iOS, Android, web, and Mac, and Windows, and Linux. So the point is that you can target all of those different platforms, but from a single code base. And that's really helpful from a development point of view, because obviously you're not having to develop a native app for the different various platforms that exist. It uses Dart as the programming language. I don't know if anyone's ever used or experienced Dart, but it's just another language. They're all pretty much the same these days, but it's quite fluent, it's quite nice to use, simple. But one of the main features of Flutter is that it has this hot reload functionality, which means that whilst you are developing an app, when you save and make your changes, they can be reflected immediately in your emulator or on your device as you're testing. Now, historically, you would have to stop your app, recompile and deploy to your device, and then go again. The benefit here is that you skip all of that and therefore speed up your dev process. So that's really, really helpful. It has a very rich UI set of widgets, and that's what Flutter calls them, widgets. So everything that you see on a screen, on an app, is referred to as a widget, whether that's the app bar that sits across the top, whether it's a button or a card or a piece of text even. These things are all referred to as widgets. It follows the Material 3 specification, which I'll come on to again in a bit later, which is essentially a specification for how most user interfaces would look and feel on a mobile device. There's slight differences between iOS, like the Cupertino style that they call it, versus what you see on an Android device. But generally speaking, Material 3 is essentially taking over from an Android and Google point of view, because this is all backed by Google. There's an extensive plugin ecosystem as well. A lot of these are backed by Flutter dev team themselves, which is backed by Google. So you can get very far very quickly, basically. And the little caveat here, the asterisk, is because although you're generally working from one code base, actually you do have native code that can live beneath that. So you can run native code on a platform. So if you're running on an iOS device, you can run iOS specific code. And that's generally exposed through plugins, which again I'll come into. So before we had Flutter, we had to develop different versions of the same app. Now, generally speaking, we're only looking at iOS and Android. Windows Mobile was around for a little while, but that got canned. So at least we were only looking at the two. The trouble was you're still looking at the two, and you're still having to develop for both. You have the same feature, and conceptually it's the same, but you have to write it in two very different ways. And as you can imagine, as being a software agency, we're trying to say, yes, we'll build you an app. And they say, okay, well, what's it going to cost? And you have to double your dev time. So essentially, it's double the cost. So Flutter effectively halves that cost. There's a little bit of overhead, but generally speaking, it's halved the amount of time required. So how does Flutter actually work? Because it's one of these things, when I first was introduced to Flutter, I was very skeptical. As I am a lot of new things, I'm very, very skeptical, because it's usually the same thing that comes back at time and time again. I've seen it before, and people are either reinventing the wheel or they're coming up with nonsense. So when I saw Flutter coming out and someone was saying to me, yes, it's just a single code base you can deploy to these different platforms, and it's just going to work straight away. And I was thinking, it's complete nonsense, because you have two or several very different platforms. You think about how you access your contacts on iOS versus how you do that on Android. These things are conceptually the same, but they're actually very, very different fundamentally in terms of how you interact with the APIs and so on. So I was thinking, oh, okay, well, they've got to transpile the code somehow into different languages. But that's not how it works. How it actually works is that Flutter, as a framework, is a UI framework. Well, it's a logic engine as well, but what it has is it has its own rendering engine. Now, to skip to the end, what it really means is that it's drawing to the screen itself, much like a computer game does. So you're not actually using the native UI widgets that come out of the box with Android or iOS. You're skipping all of that completely. And so really what you're seeing when you're interacting with the Flutter app is more like an OpenGL canvas or something like that. And it just so happens that it looks and feels like a native app. So the different platforms have different rendering backends. I'm not going to go through them now, but the point is that kind of complexity is taken care of for you by Flutter. So it's kind of like an abstraction layer ultimately. You're talking to Flutter, you're giving it a description, if you like, of what the UI looks like, and then eventually that comes down to their engine, and then eventually that comes through to the graphics API and the underlying representation on screen. So it's very clever. So as I said before, you can use native code. There are a couple of ways of doing it. There's what's called platform channels, and this is kind of a simple-ish way, let's say, of running native code. So if you take that example I said earlier about contacts or paths, getting file system paths, you think about how we can target iOS, Android, and we could target Linux or Mac or web. If I want to get the user's home directory, that just completely doesn't make sense on web, right? So what you have are plugins that will expose an interface. So that's just a description of how you can talk to something. So it's just a descriptor. So it would expose something like a method saying you can get contacts, and it will give you back an array, say a list of contacts on the device. What happens underneath the scenes is that when you're targeting and deploying to iOS, the implementation for that interface will be swapped out for the iOS version. And the same happens for the Android version and Linux and so on. So it's kind of a simple way almost to leverage native APIs. The second one there, FFI, which is Foreign Function Interface, is a way of binding to libraries directly. So that's more when you have a C or C++ library that is available on device or somewhere, and you can bind to it directly. It's much more complicated and error-prone and crash-ridden. So generally speaking, you don't ever need to do that with Flutter. You just talk to a platform channel, and it's much, much easier. And there's a whole wealth, like loads of plugins available that take care of all of these sort of little bits of complexity for you. I've just listed a few of them here just as examples. But again, if we look at some of those, like you think about the battery, some devices have batteries, some don't. It wouldn't really make sense for web, for example, to have a battery. Or geolocation, you can do it via the browser, obviously. So it uses the JavaScript APIs to do that. But on desktop, it probably won't work very well. But on mobile devices, obviously, you can use geolocation, so we all get that. If I didn't know what today's session was going to be like. I didn't know if anybody actually wanted to try and do this. But if you want to scan that QR code, if you're interested in doing this, if you wanted to get set up with your environment, then you can go there and get it done. There's different versions of Flutter and the IDEs for running Flutter. I tend to use Android Studio just because that's what I'm used to, but they tend to recommend VS Code these days with the Flutter plugins. There's a lot of help available online through what they call their cookbook, which is kind of just, they call them recipes, which is just ways of doing things in Flutter. There's a bunch of tutorials, and there's a YouTube channel as well. And the YouTube channel is pretty good. It introduces you to different Flutter widgets every now and then, or techniques for doing stuff. But honestly, half an hour, if you're reasonably capable with this kind of thing, you can get an app up and running, within 30 minutes. So there are some more topics that I've listed that I was going to talk about, but I don't know, at this point, does anyone have any questions about Flutter? Have I not explained something very well? So Flutter has its fairly lightweight rendering engines, Impeller and Skia, I don't know how to pronounce it. I've never spoken to anyone about it. It's one of those things you see written down and you never talk about. But yes, it's pretty lightweight, really, in simple terms, I think. It's written in C, C++, so it compiles very, very nicely and is very performant as a result. Yeah, because the engine can change from Flutter version to Flutter version. So yeah, but they will obviously be talking to OpenGL or whatever exists on the device. So it doesn't have to. It's not like it has to ship with all of the different libraries. It might do for the web deployment, maybe, yes. Well, yes. I mean, it produces. Well, it can be rendered to canvas, or it depends on the target. Yeah, so eventually it will get compiled depending on the target. So if I was to create an app here and deploy it just to my machine, then it's going to be compiled to C, C++ for Linux, I would imagine. So some more advanced topics. So I've mentioned Material 3. So this is what I'm going to do, actually, is I'm going to sort of take over the screen. So the Material 3, if I can see it, yeah, Material 3 spec defines basically how all the UI looks. Yeah, so it defines how all of the UI looks. So there are a whole bunch of components that you can sort of look through, so buttons, cards, and all of this kind of stuff. So you can see what the specification is like, and it helps you to discover those UI components as well and see what they're supposed to look like. There is, okay, so composition. So Flutter and the widgets in Flutter are very much, they have a preference for composition over inheritance. So when you're creating your own widgets or your pages, you do have this sort of a very big, if I can show you an example, you can have a very, very big widget tree. In fact, I'll tell you what, if I can just show you, if I can even see the screen. Let's do this. So I can just demo here, creating a new Flutter project. So it's just chalk. So if I just say, okay, so we're going to target Android, iOS, and Linux, and I can just ignore everything else for now. So you can do this yourselves, but if I now target, let's leave it as Linux, and debug that, what should happen is that we get the kind of the out-of-the-box Hello World app. And there it is. So that's how fast it is to compile. You see, it's pretty quick, right? Even though it's got the engine. And so this, you may not be able to see it very well, but here there's a little floating action button, it's called. And if I press that, it's just going to increment the number of times that I've pressed it. It's great. But out of the box, it's pretty cool that it's that quick and easy to use. And just to demonstrate the hot reload functionality, if I go and find the theme, if I just change this theme to green, if I can spell it correctly, green, and save, you see it just makes the change straight away. And that's pretty much because of the OpenGL sort of style rendering that it can do that. So if we look at, I don't know if I can increase the size of this. Okay, I don't know if you can see that any better. But this is the sort of out-of-the-box app, Hello World app that Flutter produces for you. And there's a hell of a lot of documentation here because obviously it's expecting you to be new to all of this stuff. But if I take a look at this here, for example, we have a scaffold, and the scaffold is essentially your screen, your page, if you like. It just holds everything else together. We have what's called an app bar, which is this bit at the top of the screen, and you can see that it has a title which is defined up here, Flutter Demo Homepage. So if I just bin off that and save that, we should see, yeah, Flutter Demo. So we also have the body of the scaffold, which is essentially this central part of the screen. And from there, that's where you can make all sorts of changes. And you end up in this situation, like I said before, where you have quite a big nested tree of widgets. So if I add some padding in here, for whatever reason, it's not going to be visible, I would imagine, because it's centered anyway. But if I was to wrap this column in a card, save that, we should see visually, I don't know if you can see that because there's the contrast on the screen, but there's a card there and it's, well, it looks pretty rubbish currently. But if I wrap, you can't see it. You can see it. Okay. I can't see it from where I'm standing. Okay, so if I wrap that in some more padding, just to give ourselves a little bit of breathing space, you see there's a bit of what on Android Studio or here. Okay, let's try. I'll get back to my desktop later, and there'll just be just column. Yeah, that's it. Okay, so here, yeah, we've got a bit of padding there now. If I take a look at the column, because the way that columns are laid out is that they will stretch to their parent size. So in the layout engine, so if I say main axis size, because a column's main axis is vertical, and I say, well, main, if I can type, yeah, min, then what we should see is it becomes as small as it can do, but it's still centered. So if I ditch the center, then it will probably move off to the top left or something like that. So if I remove that, save that, so it moves to the top left. So you can see how quick it is to develop and your sort of UI layout. But yes, you do end up in this situation where you have a whole sort of nested set here of widgets. And all we've done so far is add a card and some padding. As soon as I add some more stuff in there, it's just going to become a bit of a nightmare. But that there is referred to as the widget tree. And for better or worse, that's how Flutter have done it. And they like composition like this rather than inheritance. Now, I could refactor a bunch of this. I could make this into my own widget. And I could put that card in there so that in here, I could just refer to that card instead. Simple. What else do we have on the topics? So themes. So Flutter has inbuilt support for theming. So it's very similar to how you have CSS in HTML. So you describe how stuff looks and feels with CSS. So in here, we've got a color scheme, but I could change the default look and feel of a card. So the default look and feel is to have it slightly rounded like this with a border that looks like that, but I could make all cards yellow background or whatever by default. I've sort of talked about the widget tree. So in Flutter, you have something called the build context. So the build context is kind of like a locator. So it's a way of my widget that's being built. So this screen is still a widget. It's a way of saying this is where you are in the widget tree. And with that context, I can do some clever stuff. So I could look up the size of the screen, for example, from there. And the way that it works is that when you're talking or using a build context, you can, when you interact with it and ask it for something like the screen size, you're not really talking to the build context. You're speaking to an object that's higher up in the widget tree. So it kind of says, right, this is your widget. This is where you are in the widget tree. And if I say, well, what's the media query or something like that, the size, it will start navigating up the tree until it finds that media query widget. And it will ask it for its size or something like that. So if I was to try and do that now, so if I just say width or something, no, yeah, that's the one. And I'll tell you what, if I move that, if we put it in here, and then we just render it. Okay, so size and then width. And I don't know if you can see that there, but it says size 1 to 80. So simple as that, really, just to start querying for things like screen size or whatever. So I guess the point is that it's pretty easy once you know how. And that's the difficult thing with Flutter, is that it's the once you know how bit. But there are a whole bunch of those tutorials that can sort of give you these little snippets, insights of how to do this stuff. And there's a whole library of tutorials that you can query and look for that have very common sort of use cases like offline functionality and local data storage and all of that kind of stuff. What else have we got? Const widgets. So just like in any other language, you can define stuff as const here. So it's unchangeable. And the clever thing about Flutter here is that where I've got these two objects here that are actually the same, So they're defining edge insets all, so a rectangle, saying 8 units. What Flutter will actually do here is it will reuse that same underlying object to represent both. So even though I've written it twice here, because it's const, it's going to understand that when it compiles that it's only referenced in one place. And so that kind of optimization makes Flutter quite performant, actually. And generally speaking, it's good practice to make stuff constant if you can. So this piece of text can be made constant. My other piece of text, because I did remove that as I was going to edit it, but I can't make that constant because the width isn't constant. It could change at any time. So I get an error there. What else? Stateless versus stateful widgets. So Flutter has the concept of stateless and stateful widgets. So something that's stateless is just something that just takes some text, say, like a piece of this text here, and doesn't ever change. Doesn't need to react or respond to anything. But an example of a stateful widget is like our screen here. So I've defined, or the home page that they give you here out of the box is a stateful widget. And really what that means is that it hangs on to some kind of state. So it stores something in memory about what's going on. And in this case, there's a counter. So here you can see that it defaults starts at 0. And then every time I press a button, what happens is we increment it. But we also call this set state method here. And that essentially tells Flutter that I'm changing the state of my object, and what Flutter will do is it will then rebuild the widget tree where necessary. So in this case, it's going to rebuild just my one screen or one part of the screen. And that also makes it performant because it doesn't have to redraw the entire screen, just the thing that's been affected. We have support for asynchronous functionality. So much like many languages these days, you've got async, you've got futures and awaits. So you can await a future to get its result and see what happens after. And the syntax is quite easy to use. I don't know if I can just make something up quickly. You wouldn't do this in the build method because that gets called quite frequently, or as and when stuff changes. So this is purely just for example. If I was to have a timer, timer periodic, or I cannot remember. Oh no, okay. So I've just a stupid timer that's going to run every second, but you could await the result of something. I've not explained that very well, I'm sorry. But basically you have things that you can await, like an HTTP request, send the request off and await the result, and then do something with it. Flutter also has events, I guess. So they're notifying events where you have a provider of events and then a consumer of those events. And again, they are just widgets that live in the widget tree. So you might have a provider of an object. So let's say, well, when we're developing our apps at Switchplane, we tend to have an object that's called the app state. And that app state just holds useful information about what's going on in the app. So it could be the person that's signed in, for example, or their email address or something like that, or just the status of whether they are signed in. And that app state would be made available in the widget tree so that if the user was to log out and their status changed to log out, then the rest of the widget tree can just respond to that happening. It's not like I have to program that into every single screen or every single widget to understand that. It's just somewhere in the widget tree that when the user logs out, then the screen swaps out various bits of UI. I don't know where to go from here, really. That's kind of it. So I don't know. Does anyone have any more questions? Droned on long enough? Yeah. Well, I think Flutter's probably been around for about 10 years now, which I guess means it's past that threshold of being the new and shiny thing. Because in the very early days, so Flutter's on version 3 point something now, like 3.3 something. In the very early days of version 1, it was really frustrating to use because there would be breaking changes all the time and not defined as breaking changes as well. So you would have an app in production that then does just break the next time you come to develop it, which is not a nice place to be as a developer. So actually that problem has kind of gone away, I would say. There's still a few headaches, but it's grown up a lot since that version 1. I don't know, in terms of the number of apps, I don't know, but I know Google was very much pushing it, and they at least started to replace the Google Play Store app with Flutter. Whether they completed it, I don't know. And Google, as we know, are renowned for just canning stuff. But this seems to have survived. So, and it makes economic sense as well, like business case, in terms of cost point of view. So, yeah. Well, there you go, 1 million apps. Any more questions? No? No? Okay. All right, well, there you go. I don't know, if anyone did want to look at getting their environment set up, I'm happy to help, but I appreciate it might not be for today. But if anyone does want to, send a message and we'll sort it out. Thanks very much, guys.